So we are ready today to take notes on 9.3. So again, paper and pencil, and we are going to derive the law of sines. Law of sines. How are you guys doing? Hope you're doing well. And I would like you to draw the following triangle on your paper. This is a really fun proof. So let's label this capital A, capital B, and capital C. Across from the capital A would be little a. Across from the capital C would be little c. Across from the capital B would be little b. Now, from the last section, I want you to remember or look in your notes what the area of the triangle is. We use capital K. It's 1/2. Let's say we used C times B. We'd have sine, let's see, sine of something, or we could use 1/2, let's say A times B, sine of something, or we could have 1/2, let's see, what am I missing? A times C, sine of some angle. So from yesterday, or whenever you did this, if we look at the first one here, C times B. So if I take side C and side B, what angle would I need to use in this formula? Would it be angle B, angle C, or angle A? So if you yelled out angle A, that is correct, because angle A is the included angle. Let's look at the next one. We could use A times B. That would be A times B. What is the included angle there? That would be angle C. And the last one is C and A. What is the included angle? That would be angle B. So let's do something fun. Let's take all of these formulas that we can find the area of this triangle. Let's divide every single one of these by 1/2 A, B, C. So I'm going to take all of these and divide them by 1/2 A, B, C. And I'm going to divide this by 1/2 A, B, C. Am I dividing by 0? Could A be 0? Could B be 0? Or could C be 0? Think about that a minute. They cannot be zeros because they are all lengths of a side of a triangle. So none of them could be 0, so we're okay. So let's see what happens here. The halves cancel, the C's cancel, the B's cancel, and I end up with sine of capital A, angle A, divided by little a, the side, equals, let's look at the next one. The halves cancel, the A's cancel, the B's cancel, and I end up with sine of C divided by little c. Are you saying, this is so cool, just love it, Mathemagica? Cancel the halves, cancel the A's, cancel the C's, and I end up with sine of B divided by B. This is the law of sines. So we're going to remember this. We're going to be using this in our homework. Make sure you have all that written down. If you need to pause, go ahead and pause the video. I'm going to erase this. I want to talk about number 1 on your homework tonight. So your bookwork. And number 1 is a strange problem. So I just want to take 1 minute and talk about that. It tells you that you have a triangle where you know what B is, the length of B, it's given. You know what the angle of A is. So this is fixed. Those two things are fixed. We don't know how long let's make a C up here. We don't know how long little case c is. We don't know where it goes because we're trying to think about this side as A. Maybe it comes straight down and makes a right triangle, or maybe it comes here, or maybe it comes, A comes out here. So you have different options depending how the length of A. So let's focus on A. Let's pretend that A fits perfectly into a right triangle. So let's say A is the perfect length that forms a right triangle. If this was the case, then we can use what we learned in 9-1. We know that the sine of capital A, angle A, is equal to opposite over hypotenuse. And we're going to take this proportion, we're going to cross multiply, and A times 1 is A, and B times sine of A is B sine of A. So I know that this is true only if the triangle is a right triangle. Is right. So on number 1, what it asks you is well, let's, this is number 1A in your bookwork. So number 1A says, how many triangles, if A is smaller than B sine of A? So it wants to know how many triangles can you form? Oops. Can you form? Can you make? That's what the question is asking. And so basically number 1 has 4 questions in it. There's a B, and there's a C, and there's a D. So and a D. So you have to think, what if A was shorter? It only went to here. It didn't go all the way down to make a right triangle. How many triangles do you think you could make? I'm not going to answer it for you. You can think about that. What about if these two were exactly equal? We already answered that here. There would just be one right triangle. One triangle. Then it says, what about if this length, what about the length of A if it was bigger than something that makes a right angle, but smaller than B? So basically they're asking, let's say the length of A comes down a little longer than making a right triangle. Then it could swing in this direction and swing in this direction. So I don't want to give everything away. I just wanted to start that problem for you. I hope you're having a wonderful day. And again, I miss you guys, and I will talk to you later. Thank you.